Welcome to Statisticians Hub. In today's video, we will be discussing about mathematical expectation and its properties. So, let us first understand what mathematical expectation is. Mathematical expectation, also known as expected value, is the summation or integration of possible values from a random variable. It is also known as the product of the probability of an event occurring and the value corresponding with the actual observed occurrence of the event. For example, a gambler might be interested in his average winnings at a game and a businessman in his average profits on a product and so on. The average value of a random phenomenon is also termed as its mathematical expectation or expected value. Now, we will explore about mathematical expectation in case of a discrete random variable. If x is a discrete random variable that takes the values x1, x2 up to xn with probabilities p1, p2 up to pn respectively, then the expected value of x will be expectation of x is equal to summation over I goes from 1 to infinity pi xi, where summation over I goes from 1 to infinity pi is equal to 1. Again, if x is a continuous random variable with PDF f of x, then the expected value of x will be expectation of x is equal to integration over minus infinity to infinity x into f of x dx, where integration over minus infinity to infinity mod of x f of x dx, which you can also write as integration over minus infinity to infinity mod of x into f of x dx, it is less than infinity. Or we can say summation over x mod of x into f of x, which we can write as summation over x mod of x into f of x less than infinity. Here I want to add that mathematical expectation is extremely used to find out the moments of a distribution and it has great importance. Now we will be exploring about the properties of expectation. So property number 1, which states that if x and y are random variables, then expectation of x plus y is equal to expectation of x plus expectation of y. It is known as the addition theorem of expectation. Number 2 property is the multiplication theorem of expectation. So if x and y are independent random variables, then expectation of xy is equal to expectation of x into expectation of y. Property number 3 is if x is a random variable and a is a constant, then expectation of a into psi x is equal to a into expectation of psi x, and expectation of psi x plus a is equal to expectation of psi x plus a. So basically the constant part gets separated where psi x is a random variable and it is a function of x and all the expectations exist. 4 number property is if x is a random variable and a and b are constants, then expectation of ax plus b is equal to a into expectation of x plus b. Number 5 is, which is an important property, is the expectation of a linear combination of random variables. So if we let x1, x2 up to xn be any n random variables and a1, a2, an are any n constants, then expectation of summation over I goes from 1 to an ai xi will be equal to summation over I goes from 1 to an ai into expectation of xi. Property number 6 is if x greater than equal to 0, then expectation of x will also be greater than and equal to 0. Number 7 property states that if x and y are two random variables such that y less than equal to x, then expectation of y will also be less than equal to x. Number 8 is mod of expectation of x less than equal to expectation of mod x. Again, 9 number property is mu r dash exist, then mu s dash also exist, where 1 less than equal to s less than equal to r. Mathematically we can write like this, which means if expectation of x to the power r exists, then expectation of x to the power s also exists for 1 less than equal to s less than equal to r. Lastly, property number 10 is if x and y are independent random variables, then expectation of hx into ky is equal to expectation of hx into expectation of ky, where h dot is a function of x and k dot is a function of y, and here all the expectations exist. We also have property for variance. It states that if x is a random variable, then variance of ax plus b will be equal to s square variance of x, and A and B are constants. From here we can get some corollaries. So number one is, if b equal to 0, then variance of ax will be equal to a square into variance of x. If a equal to 0, then variance of b will be also equal to 0. If a equal to 1, then variance of x plus b will be equal to variance of x. And property for covariance is, if x and y are two random variables, then covariance between them will be covariance of x comma y equal to expectation of xy minus expectation of x into expectation of y. And if in this case x and y are independent, then covariance of x comma y will be 0. So here are some of the remarks. They are covariance of ax comma by will be equal to ab covariance of x comma y. Covariance of x plus a comma y plus b equal to covariance of x comma y. Covariance of x minus x bar by sigma x comma y minus y bar by sigma y is equal to 1 by sigma x into sigma y, covariance of x comma y. Similarly, covariance of ax plus b comma cy plus d will be equal to ac covariance of x comma y. Covariance of x plus y comma z will be equal to covariance of x comma z plus covariance of y comma z. Covariance of ax plus by comma cx plus dy is equal to ac sigma x square plus bd sigma y square plus ad plus bc covariance of x comma y. So I hope that you found this video insightful, and if you like this video, then give it a thumbs up and don't forget to subscribe. Thank you.